Hello, everyone, and a warm welcome to the Autodesk Fusion webinar. I'm Thomas Carlson, and I work for Autodesk Learning Partner distributor. Our company is called Knowledge Point, and we work with Autodesk and specific partners to deliver various learning and training opportunities on their software to end users, whether it's people in industry, students, or educators. Let me just briefly introduce the Autodesk Learning Partner channel. I mentioned in the intro that Knowledge Point is a learning partner distributor, and this means that we manage this program on Autodesk's behalf in a region called EMEA, so Europe, Africa, Middle East, and the CIS territories. Autodesk Learning Partners are training organizations that have been authorized by Autodesk to deliver training on their products to software end users. We, as a distributor, support these partners with different initiatives and programs in order to ensure that they, in return, can deliver the best training possible to you and your teams as you start adopting the Autodesk technology. I'm proud to say that in our region, we have more than 200 of these learning partners who are covering all of Autodesk product platforms, Autodesk Fusion, which is the centerpiece today, but also the extended product portfolio. Another thing they all have in common is that their instructors are so-called Autodesk certified instructors, which is a global brand and a stamp of quality. An instructor needs to go through training and training delivery and deliver training themselves in order to earn this status. So what it is a stamp of quality and reassurance for you as end customers that by working with a learning partner, you know that Autodesk has tested and supported their instructors. So again, they can deliver the best training possible to you. So that's just a brief overview of what we work on and the opportunities to learn more and work with a in-region partner for your teams as you start adopting Autodesk software and technology. But the main focus of this call is on Autodesk Fusion and doing a test drive. And I'm happy to share that we've invited one of these Autodesk certified instructors. His name is Steve Taylor, and he's actually reached the highest tier. He's a certified instructor platinum. So he's got extensive experience of teaching and delivering training specifically on Autodesk, different technology, but Fusion is the center points. So we're really happy to have him here. We've asked him to walk you through the main features in Fusion and give you a flavor for how this platform works. So Steve, thank you for joining us, and I'll hand over to you to do some further introductions and take it away.
Right, well, hopefully I've just shared my screen now, Thomas. So again, thank you everybody, and thank you Knowledge Point for inviting me to attend this session with everybody. And hopefully over the next half an hour, 45 minutes, I'll just give you a real good flavour of Autodesk Fusion and how it can transform your business and the impact that it can have to your employees and your productivity. So without any further ado, just a quick overview of who I am and what I actually do from a day-to-day perspective. As Thomas mentioned, I am an Autodesk certified instructor platinum. So I've been delivering courses now for over 10, 12 years now. I can't remember. It's been that long. I work for a company in the UK called 3D Great Britain and Ireland, or 3D GBIRE. In that role, I am an additive manufacturing consultant, training provider, support and applications engineer. So I do a whole wide range of activities, of which Autodesk Fusion is one of the core elements. Whether I'm creating parts for 3D printing, whether I'm reverse engineering a broken part from a stand model, I do that all within the Autodesk Fusion platform. Prior to that, from an education perspective, I was actually a leader in education. So I spent 14 years in the UK in secondary education, from design, technology, engineering, STEM, and careers education, delivering all them to 11-year-olds to 16-year-olds. And then prior to that, I was actually in industry for 18 years, working from a technical apprenticeship through to being the UK contracts manager for a global organisation company. So it's I've got extensive use of actually using design softwares from probably the mid-80s when I first got involved with it. So what is Fusion? How do we use it? How will it benefit you? Fusion 360 enables true end-to-end product development. If we look at how traditional software used to work, you'd start off with potentially, if we're looking from the conceptual design through to manufacture phases of a design project, you may start off with one particular software, SolidWorks, Siemens, Creo, CATIA, even Inventor back in the day, where you would actually potentially come up with various ideas, conceptual designs of a product. Then potentially you'd have to export that to be able to actually do some topology optimization of the actual design itself. So you'd be going into potentially a different software. And then once you've done that, you'd then export that out, and then you'd be looking at, maybe Siemens NX, CATIA, Alta, to actually do some confirmation that that actual product will do. You do some simulations, you do some studies on it, some stress studies. Will it actually do the function that you expect? Will it hold the loads? Is it fit for purpose, the design? So again, you're going into another potential software. And then finally, once you've actually come up with your conceptual design, you've tested it, everybody's happy with the form, the function, and that it will do its actual task, you then have to manufacture it. So again, another exporting from the design software and going into a manufacturing software. Now, as you probably all know, every time you export a file from one software to another, you're looking at, does it need to be a step file? Does it need to be an STL file? Does it need to be an IGES file? An OBJ file? And every time you're exporting it, you're potentially losing data. And it's getting more and more complex depending on the topology and the shape of the component that you're doing. You may be losing a lot of that fine detail. So Autodesk addressed this with this Fusion and look to bring the whole design workflow from conceptual design all the way through to manufacture within one platform, and that is Autodesk Fusion. Originally it was called Fusion 360, but over the last year the actual name of the software has gone down to Fusion. When we're looking at conceptual design, within the platform, you're able to very, very quickly iterate and provide the CAD. You're able to optimize. Now in Fusion, it's just changing a different workspace. So you're not exporting. Fusion uses workspaces, and you're just able to transfer from one workspace to another. You've got the ability to do your CAE, to do your evaluation, your analysis. With things now within Fusion, we've got generative design. So we're actually able to actually let an AI in the cloud run iterations on a part, given what materials are available, what manufacturing is available, and what stresses and forces the part is going to be subjected to. And the AI will come up with designs for you. And then finally, you've got the ability to actually see whether it is manufacturable without having to export it into a third-party software, test and say, oh, well, actually, we can't machine that, and then bring it back into the design. So that's all within one platform. And even more, this is semi-cloud-based. So even though you are working on your computer, on the software on your computer, you're able to actually save all your data in the cloud securely. That makes it better for data management and potentially for collaboration, as you can have multiple users invited to projects to be able to collaborate, comment, work with the designs collaboratively. So and it doesn't matter where you are. And another beautiful thing about it as well is that you're able to view your designs on your smartphone, on your iPhone, on your iPad. If you're an educator or in education, then you've even got the ability to have a fully cloud-based version or access to a virtual server that means that you can use Fusion completely in the cloud. Whether you've got a Chromebook, whether you've got an iPad, you've got the full capability of doing that. So let's have a look at Fusion in practice. So one of the things that I want to do, first of all, is just look at the design side of it. How quickly can we iterate and design it in Fusion? And rather than do def file PowerPoint, I find sometimes the easiest thing to do is just whack straight into the software. So this is Fusion itself. Up on the top left-hand side, we've got 9 little dots, sorry, show data panel. If I open up that data panel, this gives me access to my cloud library. Now, if you're used to using cloud, whether it's through the Windows, more Microsoft Cloud, or whether you use Google Cloud, it's very similar with the Autodesk Fusion Cloud. All your files, all these particular products are up in the cloud, and you have access to them wherever you may be in the world. You can easily create projects. So I open up a project and I call this knowledge point. Call it 2. You've already got one called 1. That creates a webinar or a project in alphabetical order, which I can pin to the top, which allows me to have quick access to any of my particular projects that I'm currently working on. When I go into it, I'm now able to create folders and file structures. I'm able to upload details in here, files. Now, it does have a one-tab uploading. If you upload a CAD file from another company that's been created on a different software, Fusion will try to create a Fusion file from that straight away. So when you open it up, it will be a native Fusion file that you will be creating. And it's called OneCAD on that. To upload anything, if I just click on upload, I can quickly select a file from my local drive. If I go to downloads, let's see if I've got anything here. Well, this will just be an STL file. Hold this, upload, and that will upload the file to this particular project. Now, I can also create folders within this side of it. So if I have data sets, or I want to call it new prototype, I can create complete separate folder types in here. That one. And also with this, you'll notice I've got a people's tab up at the top here. Up at the top there, I have this people's tab. What this allows me to do when I click people is add members. So I can invite through email addresses people to either take part in my stream as a collaborator or just as a viewer. So someone that can actually just come in, they have access to view the files that I'm creating, but not actually physically editing. So that's through that there. Again, more detail will be provided on the full training courses. So I'm just going to go through a quick workflow of potentially how I might now create an enclosure. In fact, the enclosure that I showed you recently. So what I can do is create a sketch. Now, if you've used 2D software before, it's very similar. I get separate sketch tools that I can create, and I can provide certain sizes for the diameter of the sketch that I'm producing. Once I've created my 2D sketch, I can go back into a 3D environment and I can very quickly extrude that to a certain thickness that I want. Now, as default, my material is set to steel. If this is the lens that I'm creating for the top of my enclosure, I can very quickly just change the actual physical material of this part. Now, this works also for when we're looking at the stress calculations. And all I have to do is just drag on and drop, and it converts that actual material for this part to be whichever material I've dragged onto me. If I close that now, and all I'm going to do is just save this, and I may as well keep us in the Knowledge Point Webinar 1 folder, and I'll call this lens. Now, that is just a simple process for creating an individual part. If I wanted to actually create an assembly, I don't have to do anything different from what I've just done. If I start a new design, and I can have multiple designs open simultaneously, what I'm able to do is, first of all, create a component. So in an assembly, I'm going to first of all create the base part of my assembly. I'm going to sketch on this side here now, and I'm going to come and I'm going to roughly position the size of the profile that I want to actually produce here. I can use dimensions to actually fine tune the sizes of this. 5, make that 32, make that 35 to the top. You can see I'm very quickly just adding dimensions, and I'm doing it pretty quickly because obviously I'm conscious of the time that we have for this particular webinar. And then in the spline tool, I'm going to do a control point spline. This will, still in dimension, sorry, a control point spline, which will allow me to very quickly create a spline. Now, with this particular type, the actual shape of the actual object is controlled by where these actually reside. So what I'm going to do, I'm just going to fine tune from here. Fine tune now that that's horizontal, that's vertical, and then just by giving a couple of dimensions here, got that in 25.4, and also make that exactly the same as that one. So again, parametrically driven sizes to produce these for us. Once I've finished that particular sketch, I can then revolve that round, select the center line that I'm going to, or the axis that I'm going to be revolving it around, which in this instance will be this line here, and I can create a body. If I want to put some holes in, very quickly, I can sketch on the top here. I can place a point where I want a hole. So again, very much like you might do a center pot when you're actually drilling a hole. I can very quickly make sure that that point is aligned to the center. And then using dimension, I can very quickly put a dimension in here, 44.5. Finish sketch. This then allows me to use the hole tool. And if I select that point now, I can very quickly specify a type of hole. I can make it threaded. So if I wanted and said, well, actually, I want this to be a 5mm thread, very, maybe not bigger, let's make it 6. Change that to 6 there. I can give it a depth. Let's get that 12. And it's just a simple hole that we're putting. Now, this is just a raster file. It's just a raster image. If I want to actually physically model it for 3D printing, I'll just put a little tick in this box here. Well, this little box down here. And then what that will do, it'll actually physically model the print. Now, what it is, because I actually went into a zoom function then, it removed from the selection point. If I go there, Let's change that to tack again. I said it was 6 mil, and let's put that 12 mil on model. So that's now created that particular tack hole. I can use then a circular pattern to actually pick up on the timeline at the bottom that particular feature that I've just created, and then spin that around, saying that I want 4 of them. Okay. Now with timeline modeling down here, if I want to do any changes, so say that I didn't want this to be actually a physical task, but just an image, I can go back in and I can just remove that model, press OK, and it will automatically update moving forward. So this now is just a raster image rather than the physical model. With the base now completed, what we're able to do is, in modeling terminology or in design terminology, it's top-down assemblies, because I'm able to very much go back up to my top level, create a new component, which is called, this time I'll call it the lid, press OK. We now have a new component called lid in the browser on the left-hand side, and I'm able to now sketch in place the lid where it needs to be. If I now project through some of the information previously, it picks up on that. I can finish sketch, and I can actually extrude our lid upwards. And if I call it 6.85 there, and we've now got our lid in place. I can then come in, add a couple of billets. So I put 6.85 on that one, and then add another one on the inside of the 3 millimeters. And we've now got our lid created in place. Just like with other softwares, we can actually do bottom-up assembly drawings as well. So what I'm going to do very quickly here is that lens that I created earlier. If I go to our data panel at the side, it'll open up. Come on, data panel. So we've got our enclosure that I've just created. We have our lens that I created earlier. Now, what I'm going to do is just drag and drop my lens into the environment here. And you'll notice that it comes in the bottom area. So that's actually come in where I originally designed it on them coordinates. I'm just going to pull that out and go OK. So that brings this lens in. And with all of the components that we've got here that we've modeled, we've got the ability to turn off the visibility of them and turn them back on again. So that means that I'm now able to potentially start joining these together using what we call joints. In Fusion, we have a number of different, we've got as-built joint and joint. Now, as-built joint allows you to join components where you've actually physically located them. So because I've created my lid in the correct position, if I do an as-built joint, select the lid, and then select the base itself, I have the option type here of the type of joint. It will be rigid, but just to show you, if I go to Revolute and then select the center, then you'll see that it puts in this joint, so it opens up a revolution joint. But I don't want that. For this, it is just purely a rigid joint. Press OK, and that allows us then, this is now physically fixed in position. If I hide the base, I can now use the joint tool to join the bottom of my lens into the bottom of my lid there. You will notice that we've got interference. I can inspect parts, so I can say inspect these two for interference, and it shows me here that I've got areas of interference. Now that could be a problem. However, in Fusion, it's not, because we can use this combine tool. Now, what the combine tool does, it allows me to select the target body to edit, which is this one. I can select a tool, and I've got options now to say, do I join them together? Do I just do the intersection between the two? Or do I actually use the glass to cut the base, or the lid, sorry? That's what I want. Press OK. And now we've actually got a cutout where our lens was. And if we want to add just a little bit of a clearance, I can do press pull on here and just pull it outwards a little bit to 1/4 of a millimeter. Press OK. Turn the lens back on again. That's now got its clearance, so it will fit. That's the base there. And we've got our assembler. I can bring nuts and bolts in, so I can insert components from what we call a master car component catalog. So I've got screws, nuts and bolts that I can bring in to use in these designs. I can search by various thread types. I can look for metric. I can look for round edge screws here. I can find various metric. Pick the one. And if I find one that I think that will do, if I select the product, I can actually go straight in and download the step file for it. If I download that, download, hopefully it exists in there. Try sat file and download. That would actually download the, for some reason that one was just not quick enough. So I might try a different stock component there. It's pretty small anyway. Let's do the, I actually want an N6. No, let's go N6. Probably 14mm long, 16mm long. That one. Step file. Download. There we go. So that now brings in a screw that I'm able to then join in the hole that I want. Now, I can do the handle and then add more screws, but for this, just to show you what you can do, if I do pattern of components, I select the component, which is the screw. I select the axis, which is anything on that axis there, and we want 4 of them. 30 off, but that's why axis. We want 4, and we've got them in position. Now I carry on with this, but what I'm going to do is go into the render. So if we want a good image of this, as you can see, it's in stainless at the moment. What I have the options to do is change the appearance. So if this is going to be potentially painted with metallic metal plate paint, I'm able to drag and drop onto various parts of metal paint. I'm able to add or play with the scene settings, so I can increase the brightness of the actual scene that's being done. I can put a flat ground plane in, play with the reflections. I can change the background color or even the lighting. So I can just drop in this environment here and change the types of light. And just turn up the relationships. Whilst I'm doing this, at any point in time, I can just run what we call an in-canvas render, which will give me an indication of the physical rendering that it might look like when it's actually done. So, and I can zoom in and it'll start again. But this uses your computer computational power, and you can't do anything else. But with Fusion being semi-cloud based, what I can do, if I'm happy with this, I can go straight into render and I can do a cloud rendering, click render, it will save the document, and I'm going to have a gallery appear. Now this is rendering in the cloud, which means that I don't need to do anything else with it. I can come back 5 minutes time and I'll have a good rendered image. What I can also do from this is an animation. So if I've got a big animation, or I want to animate and show people how this all fits together, this is the animation side of Fusion. We have a timeline at the bottom. Currently, the initial timeline is set to 1 second, and we've got a camera operation. So as I'm zooming here, it creates this. Let me go drag the slider back. It creates that animation there. If I then change this to maybe 8 seconds, and I move this down and zoom out a little bit, I can also transpose my components. So I can come in, I can go straight to each individual component here and move each of the components with potentially a visibility trail and move them all out. Now this visibility trail. So very quickly, I can create quite a complex animation on this. Select the lid, move that up, select the base, move that down. There. Press OK on that. If I then drag this timer back, I very quickly created an animation of everything coming together. And each one of the movements I can modify and change. What we're also able to do from that is we can now create drawings, either from that original design or from the animation. If I do it from the animation, I'm just going to set it up as default. It auto selects the default size of sheet based on the actual design of the drawing and the size of the drawing that we've created. And it creates an untitled sheet for us here. I can then drop in my base view. I can say if I want to have edges showing and center marks, center lines for everything, I can put all them on. Press OK. That creates that drawing for me. And then straight away I can drag in a table up on the actual table, drag it in, drop it, and it will automatically balloon it up. I could even bring in a base view of the actual assembler here, and from that I can potentially then just project other views. Maybe I want that down to the bottom there. Do the side one here, and you open that, tick that, and I can just drag these up, and I can even add dimensions on. So again, very quickly I can create multiple drawings simultaneously within one environment. So that's very much a quick overview of the CAD side. What we've also got in Fusion is a CAM side. So we're able to very quickly run CAM profiles through our design. So again, just quickly going back into Fusion, I've loaded up this particular part here. And all I'm going to do, just demonstrate very quickly. You can see we've got, within the manufacturing environments, we've got milling, turning, additive, inspection and fabrication possibilities. I'm just going to stick with milling in this. We have 2D capabilities, 3D capabilities, and we've got multi-axis, so we can do up to 5-axis manufacturing. Just going to create a new setup. From this, as default, it comes up with a default relative size block, which you can actually change. So if I said that it is a fit size block, in there it'll change to a fit size. I can then position where I want my model within the block. So looking at this now, I'm just going to round it down there. And I'm going to change these sizes now. So I'm going to pick a size of stock that I can potentially get off the the shelf here and the Z height there, that's about 50. But rather than having the model being central, from a height perspective, I can actually offset it just from the top, maybe 0.5 millimeter there. So what that does, that will offset from the top, there, offset 0.5 millimeter. So what that will do, that will bring that down in there. Now, also, what I can do is I can position exactly where my Z-axis is. So currently, if my milling machine, my Z-axis is going up, if I just pick the stem of that and that face, it will position it this way. Again, because I've now relocated this, I just need to change the center of the stop in the X, Y, and Z. So let's change that one now to, well, that's perfect. I just need potentially to make it wider in my Y. So let's make that 50. There. Height wise, I can probably got to get 2 meters on there. So let's say I'm down to 45. Even 40, I think I might get a little bit 40 on that. So very quickly, you can see how you can adjust and iterate the sizes that you've got. Press OK. And then I'm straight away, I can come in, and if I did a 3D adaptive cleaning on this, selected the tool that I want, there we go. So let's say that we're going to use a, I don't know, a 1/2 inch. Let's do a bone wash whistle. Select. I'm going to just pull this out so you can see the names of these. With an adaptive clearing, I don't need to pick any geometry because it's just going to select all. I can do some containment, so I can actually say I don't want to go all the way down to the bottom. I just want to machine to potentially this height here of that base, but potentially go past it by 1 millimeter. I could work with passes. You can see there's lots, just like if you're using any other 3D manufacture software, you've got all the options within Fusion to really with speeds, the types of tools, etc. in here. If I go OK on that, what this will do, this will actually produce my toolpath to actually create this. But I think the tool might be a little bit big for it, but this is just for demonstration purposes. But I can also simulate to see how potentially this tool might be used to actually rough out my part there. And the beauty about any of this, if I decide that I need to change, I can go in, I can edit, I can potentially change the tool. So if I then change that down to a different, so rather than being a 1/2 inch, if I said, well, I can only use a 1/4 inch like a mil in there, select. If I now go OK on that, you'll see that the optimal load is too much. It's saying it's trying to cut too much there. So if I come in here, I can change my optimal load, maybe down to 3 millimeter, press OK. And what we may find here, it's quickly working out. It's a much larger toolpath. It's actually machining down to that area there. And again, if we go to simulate, there is a little bit of an issue up at the end. Now that will be potentially a collision with the stock. So really this it's telling us that this tool is not really long enough. And with stop on collision selected here, we can actually see. So if I now press the simulation and press play, I can speed it up and I can see how it's working its way down. And you can see straight away the tool is not long enough. So I need really a longer tool to work with this. So this is all shown within Fusion. So it shows you where you fail and where you need to change. And just it works intuitively with you. Once you've actually got that potential program, you're then able to create setup sheets, which will potentially provide you with the, oops, come up on a different page, pull that across. So a setup sheet for all your tools and operations. So as you build up a number of operations, you'll have your full list of tools there, but also you're able to post it out to a G code, which again is popped up on the screen here. So I've got a certain output that I want. I don't know whether this is the right process for it. And it would again potentially produce that. If I can get this across. There we go. And that's produced the G code. Again, depending on the movement and the tools and the machine that you're using. It's just selecting the right code process at the moment. Now, finally, one of the things I just wanted to touch on is generative design in Fusion. I know there's been a lot of talk about it, a lot of people talk about it and how it can help and work with you. Well, actually, generative design Fusion, what is it? It's design exploration. This is this AI in the cloud that you can run. It's a bit like running a stress simulation study or a topology optimization, but it takes in not just materials, but multiple different materials. It takes into account the loadings, the manufacturing technologies that you've got available, and whether it's 3-axis, 5-axis, 2.5-axis, or additive, you can put them in. And what it will do, it will plot out a table and give you success criteria as a result. As I said, it takes in manufacturing intelligence. So whether it's 2-axis, 2.5-axis, 3-axis, etc. And then from your result, not only can you actually get a mesh from that result or an STL from that result, you can actually get an editable model. So something that you can go in and you can fine tune from it. And just as an example of that, what I do have, let's use it now again. Oh, I had it already on, sorry. There we go. In Fusion, this is just an example of some results that potentially have come out. And each one of these results I can view, and we can actually see how, through iterations, how the software has iterated and started removing material. Now, this particular example that I've got here, if I finish looking at the outcomes here, you can see down the side that I've got a number of generative models, a number of studies that have been done. We've got filters. So here, we've got, if we've got unrestricted, this will remove the unrestricted ones. If we've got additive, which will remove the additive type of technologies. Casting, the types of materials and studies that have been done. We can look at it and view it in graphical form. So we can look at the minimum safety factor versus the actual mass on here. We can change that and look at the mass. And each one of these has a key. You can hover over it and you can see exactly which outcome refers to which particular type of material and type of manufacturing technique. To actually set up something like this, a study, you could have started off with an initial design idea like this. And the idea on the design is we are replacing this bracket for the caster wheel. So we need to keep in this top bit because that inserts into the leg of a chair or a table. We've got the wheel that we need to keep, and we also need to have a shaft through. So through the generative design study process, we create something called obstacles and preserved geometry. So the preserved geometry is the green. So these need to be in our design. Let me take this so you can see that. So the green is what needs to be within our design, and the red is where we cannot have any material connecting. So the actual software is going to try and connect these green preserved geometries together, but avoiding these red geometries. And from that, that's when we get these results. And we can get downloadable models here. So we can click design ready to continue, open design. And this will then, it says, open our design model in the software. And it is all editable. So if I go in the timeline now, find the organic form, which is this part, I'm able to use the soft modeling technique to actually be able to pull out surfaces, modify parts of my design in any form or place either. Okay. And if I then, at the end of it, I want to 3D print this, I'll get a file from it, an STL file. In my bodies, I've got body 10. I can just right click and save as mesh. So I can export it straight as a mesh and then put it into my 3D printer, or I can go straight into the manufacturing environment and put it straight into the additive side there. So I know that was a whistle-stop tour of it, but that really brings me, hopefully on time for Thomas, to the end of my little demonstration here.
So we hope that this gave you a good sneak peek on what Fusion can do and an appetite for more, as I mentioned. Then we'd be happy to connect you with our learning partners.